Hello friends, welcome back to CIVILDEPTH-BD. Today I will show you how we can determine the allowable design axial load for this 12-inch square short tight column reinforced with 4 number 9 bars. Ties are number 3 spaced at 12 inches. Use F'C equals 4 ksi and Fy equals 60 ksi. Step 1. At first, we will determine the allowable design capacity of this column. The smallest dimension of the column B equals, here I will use 12 inch. Longest dimension of column, here same value 12 inch. Gross area of column, this Excel will calculate automatically. Compressive strength of column F'C, here we have to take 4 ksi. So input 4. Yield strength of rebar, here I will use 60 ksi as per this problem statement. Smallest longitudinal bar in column. For this column, there is only 4 number 9 bars, but if you have a separate dia bar in your column, in that case, you have to input the smallest longitudinal bar dia here. Okay, here I will use number 9 bars, that means 29 mm dia bar. So input 29. Number of longitudinal bar N1 equals 4 nos as per the problem statement. So area of longitudinal bar equals 4.0924 inch square. As I said earlier, if you have a separate dia rebar in your column, in that case you have to input other longitudinal bar dia here as D2. Number of longitudinal bar N2, for this case it is 0. Area of longitudinal bar AST2 equals 0. Since this value is 0, all other value will be 0 for this other longitudinal bar dia. Now total area of longitudinal bar equals AST1 plus AST2, okay, equals 4.09 inch square, because this value is 0 here. Otherwise, suppose if it has a value, suppose now you can see that this is accumulating this AST1 and AST2. Okay, now go back. So total area of longitudinal bar AST equals 4.09 inch square. Tie bar dia equals D3 10 mm as they have said. Number 3 bar. Phi equals 0.65 for tight column. For spiral column you have to use 0.75. K equals 0.8 for tight column, and for a spiral column the value will be 0.85. Basically we have to calculate the design capacity of this column by using this equation. Now we have all the data. I have inputted all the data here. So allowable design axial load capacity PU equals 375 kips, or you can say 1668 kilo Newton. Okay. So if you need to create this Excel sheet, just follow this equation and input all the values in the Excel. Okay. Now step 2, we will check the rebar percentage. Rho G equals small ast divided by AG. So it is it has been calculated by the Excel that the value is 2.84%. If the value is less than 1, it will say redesign. Similarly, if it is greater than 8%, the Excel will indicate that redesign, because as per BNBC and ASC code, reinforcement ratio must be between 1% to 8%. Okay. For step 3, check tie spacing. S1 equals 18 inch by following this condition. 18 inch again by following this condition. 16 times the longitudinal bar diameter. And the third condition, which is the least dimension of the member. Excel will automatically select this value from the given data at smallest dimension of column. So given spacing, that means in the problem statement they have told that they are interested to provide number 3 bar at the rate of 12 inches center to center. That means S3 equals S0 equals 12 inches. Finally selected spacing as equals 12 inches. That means the minimum value between these four. Okay. So by this way we have completed the design procedure of a axially loaded column. So that's all for today. See you in the next tutorial. Thank you.